You probably know by now that we are building a collection of AI models that look like me and talk like me and have access to all of my personal information.
That seems safe.
Yeah. It's called Synthetic Self.
And what's the first step to go from standard human person to AI copy?
Text to speech! Hi, I'm Em.
And I'm Steve.
And together we are Blink, Pop, Shift, a disability futures lab out of San Francisco.
We use art and technology to prove that disability is a hotbed of innovation. And right now we're building a new voice for Synthetic Self.
If you saw our last video, you probably saw that the current voice leaves something to be desired.
Because our goal is to make a voice that isn't dependent on a startup API that fails and borks our whole project.
So unless it's absolutely not possible, we are sticking with open source.
Our first attempt at using a voice was Quarantine J, an open source tool for creating voice clones. But after many tries, the speech always came back rough and difficult to parse.
So after tons of trial and error, we went back to research mode. We need something that sounds natural and human-like. And that's when we found FastSpeech 2. FastSpeech 2 has the highest MOS score of any available model. MOS, or mean opinion score, ranks voices on a 5-star scale.
It's been a common metric for measuring call quality for decades, but now we're using it for AI.
So over the last 4 weeks, we have been focused on just understanding all the in and outs of FastSpeech 2 and all of its components.
This is going to get a little technical, but don't worry if that's not your thing. Omelet's here for cuteness support. Look how cute she is. Such a snack.
At this point, we're not even at the FastSpeech 2 stage yet. We're learning to use a tool called MFA, or Montreal Forced Aligner, to create inputs that FastSpeech 2 can even understand.
MFA lives on GitHub, so like any GitHub repository, you have to download the source code or use source control to get started. We created an Anaconda environment and installed the dependencies.
The right dependencies this time, though, right?
Well, yeah. Well,
my anaconda don't got the right Python dependencies.
Install maybe some of the wrong ones first.
And that's where the roadblock started.
The MFA documentation uses a ton of linguistics jargon that's not explained for users coming in from outside the field.
It's common for open source to come from academic environments and spend more time in the documentation explaining how the model works and less time on an actual step-by-step of how to use the thing.
So we're going to do our best to give you the TLDR.
Yeah. Step 1, record a very long chunk of voiceover audio. Use a good microphone, it matters.
Step 2, chop that audio file into 10-second pieces. We still need to write some software for this.
Ain't nobody doing that manually. Step 3 is to use an API to transcribe the audio clips. This gives you a text file of all of the words said in the audio. We're going to use something like Whisper AI.
Step 4. Hand the audio files and the text files to a model called G2P, or Grapheme to Phoneme, which creates an IPA transcription of the sounds that make up the words instead of just the text.
Step 5, and yes, we still have more steps to go, is to give the 10-second audio clips with the phonetic transcription to the Montreal Forced Aligner, and it will give you a time-stamped version of each of the phonetic components. This is called a text grid.
In step 6, we take all of that, the audio files, the text transcripts, the phonetic transcripts, and the text grid alignments over to FastSpeech 2 to create a new voice.
In case you lost count, that is 3 separate machine learning models needed before we can even test train our new voice.
Not to mention some automation software so we don't have to feed thousands of 10-second clips through this whole process.
So wish us luck, y'all. Now that we have a good understanding of all the steps involved, it is time to test our theory.
And hopefully next time we'll have a new voice to share.
And as always, we super appreciate your support in this process as we push the boundaries of art and technology. And if you know of any open source technology that might help us along in this process.
Like a WAV file chunker. That works.
That works. The first one did not work. Or ideas for how we might fund this project, let us know in the comments.
Like and subscribe to let our algorithmic overlords know that new people
should watch this video, just so that we know people will watch the video. Ignore him. And meet us back here the last Friday of every month for a new update. See you then. Are you gonna go?
Oh, just me.
I already did my line.
Oh, okay. Because our goal is to make a voice that isn't dependent on a startup API that might fail and bork our whole. You don't have any lines. But after many tries, the rough always came voice back. Maybe Faye lives. Step 4. Step 4. Like and subscribe.
What is that?
Like and subscribe.
What?
Like and subscribe to let our algorithm overlords.
What?
Like and subscribe.